All right, this is for Math 161. This is 5.6, solving logarithmic equations. So the nice thing about solving log equations is that we're usually going to switch the form and make it an exponential form instead. So the first key is going to be trying to make it so it looks like this, where you only have one log on one side of the problem. If you can do that, then you can almost always rewrite it in exponential form and have something easy to solve. So remember how we would rewrite this is we always start with our little base, raise it to the power of whatever's across from it, and set it equal to whatever's left in here. Okay, so first, again, it just takes practice knowing where to put everything. So once you do that, then look at what you have. Well, we have 2 to the second, which is really 4. And now to solve, all I would need to do is divide by 11. So x equals 4 over 11. When you're doing these log problems, make sure that if you plugged that in, you wouldn't get a negative or a 0 in here. Because remember, we never want that. So just check real fast. If I plugged 4 over 11 in, yeah, it would be fine. Okay, so for number 2, again, this is the form I want, 1 log. So let me rewrite this. 4 to the second power equals 4x minus 3. 16 equals 4x minus 3. I'm going to add 3 and divide by 4. Done. Okay, so that's one way to use logs. If you have more than one log, and there's no way to get just one log all by itself, but you can get it to look like this, log base something equaling log base something, then you can just basically ignore the logs and set the two things equal. Right? The only way this could work is if this stuff equaled 25. But now you have to remember, how do we solve an absolute value equation? Remember that we have to set up 2 separate equations, one where this stuff equals 25 and one where the same stuff equals negative 25. So we'd add 3 and divide by 4. Divide by 2 to get 14. Over here, we would add 3 and also divide by 2. But now let's check. If I put 14 in here, that would be 28 minus 3. That would be fine. If I put negative 11 in here, that would be negative 22 minus 3, negative 25. But since I'm taking the absolute value, it would be fine. So both of these would work. Okay, so I have the same type of thing going on, but I don't just have the logs by themselves. I have these numbers out front. So this time we're going to use the opposite of that power trick and put the numbers in front up as the exponents so that they're not in front anymore. So now I have log base 5 of this equaling log base 5 of this. So I can ignore the logs and say x to the 1/2 would equal 2 to the second, which is 4. Keep in mind that x to the 1/2 really means the square root of x. So to get rid of that square root, I would need to square, and x would be 16. Check. If you plugged it in, would that be okay? Yes, because that wouldn't make anything negative or 0. Okay, so far, if we have only one log, we rewrite it in exponential form. If we have one log on each side by themselves, we can just ignore them and go from there. So 4 almost had that, but we had to move those numbers to the exponents before we started. Okay, number 5. We have 2 logs. So I would like to make it where I have 1 on each side by itself, but I have this extra number that's going to be in the way, where even if I moved one of these over, it still is not going to be nice like number 3 and number 4. But remember that we know a way to take 2 logs and squish them together into 1. and it is the condensing rules, right? So if I were to take this 2 and move it to the exponent, but then take these 2 log 6s that are being added and rewrite them as 1 log 6 with this stuff being multiplied times that, I now have a problem with 1 log on one side. So I can rewrite it as 6 to the second power equaling all of this. I'm going to go ahead and put that 9 in front because it looks funny the way it was written. So basically 36 equals all of this. I can now divide by 9. Square root both sides, but be careful because when you square root both sides, you end up with positive and negative 2. And then finally, you're going to have to add 3 to all of those answers. So 2 plus 3 is 5. Negative 2 plus 3 is 1. Check both of these answers, though, back in the beginning. 5 minus 3 would be 2, but 1 minus 3 would be negative 2. So we don't want this one. So our answer is really just 5. Okay, so 6 is similar where we have 2 logs that we're never going to be able to get just by themselves. So I'm going to get both logs on one side so I can do the same type of thing we did for number 5. So I'm going to subtract this log over here. So now if both logs together, they both have the same base. So instead of having 2 logs being subtracted, I can condense them into 1 log with division. And so now I can rewrite the problem starting with the little base, which is 10 because there's nothing there. So 10 to the first power equals all of that. And now I just need to start solving this, which is a little more complicated. So I'm going to start by multiplying both sides by the x minus 1 so that it's not in the denominator anymore. I'm going to go ahead and distribute that 10. And now I have x's on both sides. So I'm going to move these x's over by subtracting. Add 10. And divide by 5. So x equals 17 over 5. And just checking, if I plugged it in, that would obviously be positive, and that would be positive, so it's fine. Okay. 7, same idea. ln x plus ln x plus 12, I can put together as just one ln of these two things being multiplied. And now I can rewrite it. E to the 4th power equals all of this. And then you're just going to have to go through and solve that, which is going to be a little tricky. So you would probably need the quadratic formula. So we're just going to leave that one from there. We're just going to at least practice starting these. Okay. So 8, same idea. Let's at least get it started. So the 2 logs can go together as 1 log. Since the 2 logs were being subtracted, it would be 1 log with division. I'm now allowed to rewrite this as 1/3 to the negative 2 equaling all this. Remember, 1/3 to the negative 2, though, is nice because the negative flips the 1/3 to just a 3 to the second power. So it's really just 9. So all of that is really just 9. And the first thing I can do is multiply both sides by the x squared minus x to get rid of it. So I just need to do that on both sides. And then start working this out by distributing the 9 and going from there. So since I see x squared and x, I'm going to get everything on one side. So if I subtract x squared, that gives me 8x squared. And if I subtract an x, that would give me a negative 10x. And then factoring, I can take out a 2x, which would leave me with 4x minus 5. So setting 2x equal to 0 gives me 0 as an answer. Setting 4x minus 5 equal to 0, I would add 5 and divide by 4. These are my two answers. If I plug them in though, 0 squared plus 0 is 0, and we never want this to be 0 or negative. So I actually don't like that answer. But 5/4 squared plus 5/4 would be fine. 5/4 squared minus 5/4 would be fine. So that's my only answer. So again, it's going to be the algebra that's probably going to be the trickiest part. All right, and then one word problem. The value V of a certain automobile that is T years old can be modeled by this equation. According to the model, when will the car be worth each of the following amounts? So it's giving us an amount and it wants us to know when it will be equal to that. So basically we're going to try to find T. So when it's giving me this new amount, it's really giving me the answer. So I'm going to have to put the 9,000 there and figure out how to solve for T. So the first thing we're going to want to do is divide by that 14,000. So we're going to do 9,000 divided by 14,111, which is giving us this answer that is not so nice. So I'm going to just write as many numbers as I see, even though that's annoying because I don't want to round until the end of this problem. And then the easiest way to bring that exponent down is to do the ln trick. So if I do ln of both sides here, then that exponent's going to be allowed to come down. So this becomes ln of all of this equaling t times ln of that. And so finally, to get that t by itself, we're going to have to divide. So whatever I have here, I want to do ln of that divided by ln of the 0.75. I mean 0.78. And I think it wanted us to round to the nearest tenth, maybe. So that would mean t would be about 1.8. So the more you do problems like this where you're just trying to solve for the exponent, you'll get the hang of just doing the ln or the log of both sides and then dividing because they'll be the same thing over and over again. So let's try one more. So what if the amount was 2,000 instead of 9,000? Well, your first step would be the same. You're going to divide by that 14,000. And again, I'm going to just write as many numbers as I see because I don't want to round. So again, if it's the exponent you're trying to bring down, we want a log involved so that we can just bring that out front. So the easiest log to use is just to do ln of both sides. So now we can bring that exponent in front. So now to get that t by itself, we're just going to divide both sides by that ln 0.78. Okay, so There's my answer that wasn't so pretty, but I want to do ln of that answer. So instead of typing that all in again, I can just hit second and then this button down here, ANS, because what that does is it brings my last answer in there. So ln of my last answer would give me this, and then I want to divide ln of that 0.78. And it makes sense that this is a bigger answer, right? Because if my car started being worth 14,000 something, it would make sense that it went down to 9,000 after almost 2 years, but it would go down even more to 2,000 after more years. So always think with word problems, does my answer make sense? Yes, it would make sense that it would be something like 7.9 years. Okay. So this one's actually not too bad as long as you get used to the trick of doing ln of both sides of the problem in order to bring that exponent out front. Okay, give these a try. Like I said, I know it's the algebra that's going to end up being the hardest part. So the more you can practice, the better it will get. Let me know if you need help as you're going through the homework.